Number 7, Georgia is purchasing treats for her classmates. Georgia can spend exactly $10 to purchase 25 fruit bars, each equal in price. Georgia can also spend exactly $10 to purchase 40 granola bars, each equal in price. We need to write an equation that can be used to find all combinations of fruit bars X and granola bars Y that will cost exactly $10. So you have a total of $10. Well, we don't know how much one fruit bar or one granola bar is. But what I do know is that we can buy 25 fruit bars to get $10. So if I want to know how much it is for one fruit bar, I could take $10 divided by 25, and that equals 0.40 per fruit bar. If I spend $10 on 40 granola bars, that's 25 cents per granola bar. So my equation would be that I could spend 0.4 times X, so 40 cents times the number of fruit bars, plus 25 cents times the number of granola bars for my total of $10. In part B, we need to graph the equation. Well, let's just have a refresher of what our equation was. It was 0.4x plus 0.25y equals 10. Well, I went ahead and found my x and y intercepts. For my x-intercept, you would use the cover-up method, cover up your y, and you do 10 divided by 0.4, and your x-intercept is going to be 25. For your y-intercept, you're going to cover up the x's, divide by 0.25, and you're going to have a y-intercept of 40. So I plotted 40, 25, and connected. What is the slope of the line graphed? So I just used my two ordered pairs and my two intercepts. I went down 40, so it's negative 40, to the right 25, which this simplifies to negative 8/5. If you wrote it as negative 1.6, that's fine. But I think for part D, looking at the fraction, negative 8/5 is a little bit easier because it says explain what the slope from part C means in the context of Georgia purchasing her treats. Well, we know that X is the fruit bars and Y is the granola bars. So these are the granola bars, these are the fruit bars. So I know if I kind of read it down, if she buys 8 less, because 8 is negative, granola bars, she can buy 5 more, because 5 is positive, fruit bars. Okay, moving on to number 8. Number 8, Hava is traveling on a train. The train is going at a constant speed of 80 miles per hour. How many hours will it take to travel 1,120 miles? So we know that it's 80 miles per hour. So my distance is 80 miles times the number of hours. And they traveled 1,120 miles equals 80h. So you divide by 80 and you get h equals 14 hours. Second part, you really had to pay attention to the wording. Ahava is also considered taking an airplane. The airplane can travel the same 1,120 miles in 12 hours less time than it takes the train. So the time is actually 14 minus 12 is only 2 hours. What is the speed of the airplane in miles per hour? Again, we know that distance is rate times time. So we know we do 1,120 equals the speed times 2. So you divide by 2 and you get 560 equals the speed. So it's 560 miles per hour. For part C, Ahava is very concerned about the environment. The graph below shows the carbon dioxide in metric tons for each traveler on an airplane and each traveler on a train. What equation could be used to find the metric tons of carbon dioxide produced, Y, by a traveler on an airplane for X miles traveled? Well, we're looking at the airplane, so I'm looking at this line. Well, I need to find two ordered pairs. Nicely, we have 0, 0 as our y-intercept. And then I looked and I found another ordered pair. And I thought, well, 500, comma 0.16. So I went ahead and I found my slope, n equals 0.16 minus 0 over 500 minus 0. So we have 0.16 over 500, which is 0.00032. My y-intercept we already know is 0, so my equation is just y equals 0.00032x. For part D, it says, on another trip, Ahava travels to her destination on a train and returned home on a plane. Her total carbon footprint. A carbon footprint just means how much total carbon dioxide was made for the trip was 0.42 metric tons. So that means that the train plus the plane's CO2 equals 0.42. Well, we already know how much a plane produces from part C. We know that it was 0.00032 times the distance that she traveled equals 0.42. But we don't know for a train yet. So we have to go back to our graph and we have to do the exact same thing. So we have two ordered pairs for our train. We have 0, 0 again, and this time we have 1,000, comma 0.04. So I found my slope, 0.04 minus 0 over 1,000 minus 0, which ends up being 0.00004. So your equation for the total carbon dioxide for a train is 0.00004x. So that is how much carbon dioxide that the train had. So I went ahead back to C and wrote my 0.00004x. When I combine my like terms, I get 0.00036x equals 0.42. Divide by 0.00036, and you end up with x equals 1,166.67. So we could say 1,166.6 repeating miles. Okay, number 9. The box and whisker plot below, shown below, represents the students' test scores on Mr. Levine's history test. What is the range of scores? Remember, range is the largest minus the smallest. So the highest score is 100. So I would do 100 minus the lowest is 60. So the range is 40. What's the best estimate for the percent of students scoring greater than a 92 on the test? Remember, on a box and whisker plot, every portion is 25%. So higher than a 92 would in fact be 25%. For part C, Mr. Levine wanted more than half of the students to score 75 or greater. So 75 is approximately like right here. Explain how you know that more than half did not score greater than 75. Well, you know that 50% scored less than a 68. So 50% were below 68, which means that you can't have more than 50% being greater than 75. So I just wrote the median is 68. So 50% of the students were or scored below 68%. Last but not least, the scatter plot, you had to draw a trend line. Should be through the middle following the data with an arrowhead. For number 10, I'm going to go ahead and erase this. The weight in pounds of each wrestler in the high school wrestling team at the beginning of the season is listed below. We needed to find the median. Well, first you need to put them in order. So the first smallest was 112, and then we had 130, followed by 142, 150, 178, and 206. So your median, if there's 6, falls right here. So you have to find the average of 142 and 50. So you have to do 142 plus 150 divided by 2, and that gives you 146. So I know my median is 146. Your mean, if you add up all of these numbers, you get 918. There are 6 wrestlers divided by 6, and you get 153. Part C is pretty tricky. It says 2 more wrestlers joined the team during the season. The addition of the wrestlers has no effect on the mean. So the mean is still 153. The wrestler's median weight increases by 3. So the median was 146, but we're adding 3. So now the median is 149. So I went ahead and I let X equal wrestler number 1's weight and Y wrestler number 2 weight. So I know that the mean didn't change. So I know that when I added up the first 6, I had 918 pounds plus X plus Y, all divided by, now there's 8 wrestlers with 153 pounds. So if you simplify, you multiply both sides by 8, you get 918 plus X plus Y is 1,224. Subtract your 918. So I know if I add up the 2 weights of the wrestlers, it's 306. Then I had to list my wrestlers in order again. So I knew that it was 112, 130, 142, 150, 178, and 206. If there are now 8, that means that I'm going to have to add 1 wrestler to the left and 1 wrestler to the right somewhere. But I know that my median increased somewhere along here. So I knew that my new wrestler, one of them, had to fit right here. So I said, well, what number could make the median 149? I solved, well, I don't know what that wrestler is, plus 150 divided by 2, it has to equal 149. So I went ahead and that had to equal that X was 148. So the first wrestler was 148. To find the second wrestler, I just did 148 plus Y is 306. Subtract your 148. So the second wrestler had to be 158 pounds.